Logarithms, inverse functions. We have learned that the inverse function of an exponential function is a logarithmic function. That the inverse of a graph is a reflection across the line y equals x. And that we can find the inverse of a point by switching the x and y values. The method for finding the inverse of any function also involves switching the x and y values. That's the first step. The second step is to solve for y. The resulting equation is the inverse of the original function. Example 1 is a linear function, the easiest kind of function to find an inverse. As the original function becomes more complex, finding its inverse also becomes more complex. All right, let's find the inverse of this linear function. So first step was to switch the x and the y values. This is written in function notation, but that is the y value. So switching the x and the y values looks like that. Second step is to solve for y. Adding 3 to both sides, we isolate our y term. Dividing by 2, we get our y value by itself. So we have y is equal to x plus 3 over 2. So the inverse function of the original function is f inverse of x is equal to the quantity x plus 3 over 2. And that's how we write the inverse function of f as well. When finding the inverse of quadratic functions, we often have to complete the square. And we must remember that when we take the square root of a square, there are two answers, a positive and a negative. And this is example 2. So we are going to come over here to example 2, find the inverse of that. So we're going to switch the x and the y. So we have x is equal to y squared plus 4y. We have to switch it in all places. So now we have to complete the square on this side. So remember, the way I do it is I put that y squared plus 4y inside parentheses. And then I have a couple spots to add some things. Now, I look at this and I say, all right, so I take half of that. So half of 4, half of 4, and then square that. And that will be 2 squared, which is 4. So I add 4 inside and subtract 4 outside. So this is separate. All right, so now inside we have x is equal to, now we can factor this. You can use the generic rectangle diamond problem if you want to. Or you can just look at it and do some work math just in your head. Sorry about that. And so that is the next step. So I have completed the square, but now I need to solve for y. So my next step is to add 9 to both sides. So I have x plus 9 is equal to y plus 2. That quantity is being squared. So the next step is going to require me to square root both sides, and this is where the positive and the negative show up. I have positive and negative, square root x plus 9 is equal to y plus 2. And the last step here is going to be to subtract 2 from both sides. So we get y is equal to, and you can write it the negative 2 in front or back. I'm going to do it like this, negative 2 plus or minus the square root of x plus 9. So this is not a function, so we're going to leave it like that. Y is equal to negative 2 plus or minus the square root of x plus 9. Think about a square root graph looks like this. So a negative square root graph looks like that. And that is not a function, so I don't write it in function notation. Notice that if we graphed the inverse in example 2, the result would be a parabola on its side. But that's not a function. Sometimes the inverse of a function isn't a function. One way to graph a logarithm is to find its inverse, an exponential function. Then you graph that exponential function and then reflect it across the line y equals x. The reflected graph would then be your logarithmic function. So in example 3 here, I'm going to change that, sorry about that. In example 3, we're going to find the inverse of that function f of x. So we switch our x and our y values, so we have x is equal to 1/2 times log base 3 of y minus 4. So now we need to solve for y. So I'm going to multiply this whole thing by 2, and that will get rid of that. Okay, so I have 2x is equal to log base 3 of y minus 4. So now that I just have a log on this side, I can convert this to an exponential form. So I'm going to do that right here. So base 3 of 2 to the x is equal to y minus 4. My next step for isolating y is to add 4. So I have my y will be isolated, and I'm going to write my f inverse of x, because that's really what y is. It's a function in this case, is equal to 3 to the 2x plus 4. Now, if I wanted to refine this a little bit, that 2x in the exponent, we could break that apart. And actually, let's just leave it right there for now. I think we've done a good job here, and we're going to leave that for now. So that is logarithms inverse functions.